Hi everyone, today I will reflect on what I learned from week 1 to 5. In this presentation, I will discuss the key Python concepts, explain how to apply computational thinking to a student grade calculator, and reflect on the differences between procedural and object-oriented programming. The first concept I learned was decision structures, which allow a program to make different choices depending on a condition. This includes if-else nesting decisions and if-else statements. The second concept is while and for loops. A while loop repeats whether a condition is true, whereas a for loop processing each item in a sequence. One important thing is that a while loop must eventually become false to avoid an infinite loop. Another important topic was lists and troops. Lists are mutable, meaning their elements can be changed, while troops are immutable, meaning they cannot be changed after creation. This concept helps me understand how to work with lists using indexing, slicing, length, and methods such as append and remove. I also learned about two-dimensional lists containing other lists and representing data in rows and columns, and list comprehensions providing a concise way to create new lists. The next concept is modules, which store reusable functions and have organized code. To use a module, we import it using an import statement. I also learned about file input and output or file I/O, allowing programs to save and retrieve data. The basic process is open, process, and close, with RWNA used for reading, writing, and appending. Functions allow a large program to be divided into smaller, manageable tasks. This assists me in studying how to define and call functions using parameters and arguments, returning values, and understanding the difference between local and global variables. Overall, these topics help me build a stronger foundation in Python. Then I learned to apply computational thinking through a student grade calculator. Their four steps include decomposition, breaks the problem into tasks consisting of receiving marks, calculating the average, determining the grade, and displaying the result. Pattern recognition identifies the common process including inputting marks, calculating the average, comparing with grading rules, and displaying the grade. Abstractions focuses on relevant information, including the student's name, marks, average, and grade. Algorithm design applies grading rules. 80 or above is A, 70 or above is B, 60 or above is C, and below 60 is fail. This experience taught me to analyze problems and design solutions before coding. Finally, I learned about procedural programming and object-oriented programming. Procedural programming uses functions and follows sequential steps to solve problems. In contrast, OOP uses objects containing data and methods that define their behavior. OOP has four key concepts: encapsulation, which controls access to data; inheritance, which supports code reuse; abstraction, which hides complex details; and polymorphism, which allows different objects to perform the same operation differently, such as dog making, parking, and cat mewing. From this comparison, I learned that OOP is more suitable for larger and maintainable software systems. In conclusion, week 1 to 5 helped me develop a better understanding of Python and problem solving. I learned the individual programming concepts such as decision structure, loop list, troops, modules, file I/O, and functions. Moreover, I also learned how these concepts can work together to solve a problem. The student grade calculator helped me understand the importance of decomposition, pattern recognition, abstraction, and algorithm design. I also learned that choosing between procedural and object-oriented programming depends on the problem type and complexity. This concept have given me a stronger foundation for developing more complex programs in the future. Thanks for listening.